Good afternoon, class. Here's pre-calculus, chapter 5, trigonometric functions. So that's the first section we are looking at, angles and their measurements. We're going to continue finishing it off. This is part 2 of angles and their measures. Example 5, the latitude of a location L is the angle formed by a ray drawn from the center of Earth to the equator, and a ray drawn from the center of Earth to L. That's the definition of a latitude. Glasgow, Montana is due north of Albuquerque, New Mexico. Find the distance between Glasgow, approximately 48.15 degrees or 48 degrees 9 minutes north latitude, and Albuquerque approximately 35.083 degrees or 35 degrees 5 minute north latitude. Assume the Earth radius is about 4,000 miles, 3,960 miles. And first, reminding everybody that arc length is calculated as S equals R theta. So we need to find the theta, the distance between the two. We have to find the angle between the two. In other words, what is given? So this is the location of the two cities. And it makes it easier to see along this circular shape. Here's Albuquerque, here's Glasgow, and here's the equator, and here's the two angles that give us the north latitude. So R is 3960 miles, about 4,000 miles. Theta 1, that means for one of them is 48.15, and theta 2 is 35.083 degrees. So the central angle between the two cities would be, okay, so we find the angle between the two, this central angle. So we're going to subtract the smaller one from the larger one, and we get 13.067 degrees. We put it in this formula, S equals R theta. Needless to say, theta must be in radians. So times pi over, we're going to multiply this one by pi over 180 to change it to radians. And we're going to multiply it by R, 3960. And that gives us the distance of 903 miles, almost. So that's how we calculate this. So we discussed the distance, the arc length. Now we want to discuss the area of a sector, a portion of a circle, then we call it a sector. Find the area of a sector of a circle formed by a central angle, and the formula is A equals 1/2 R squared theta. Understand that this or that one, if you will, it's a portion of the area of a circle. So the ratio of theta to theta 1 is A to A sub 1 if you have two different central angles. And we know that A equals pi R squared for a circle, where pi is half of the, if you look at the circle, it covers the 2 pi radians. A complete revolution is 2 pi radians. So this pi is half of 2 pi. So we are thinking of this as half of that, and this is your theta in essence. So therefore, that's the justification that the area of a sector, this is a sector, is 1/2 r squared theta. Having said that, here's the example. Find the area of a sector of a circle of radius 5 feet formed by an angle of 60 degrees, and they want us to go with 2 decimals. So we are going to use A equals 1/2 r squared theta. So what is r? In this case is 5. What is theta? 60 degrees, we should know it's pi over 3. So it's important to know we have to go with the radians. So this is 25 over 6 times pi, or 25 pi over 6, and it's roughly 13.09 because when I go with 2 decimals. By the way, you have to go to the third one to make a decision, so you want to be very careful with that. Find the area of a sector of a circle of radius 2 feet, so that's r, formed by an angle of 30 degrees, and we all know that is pi over 6. So A equals 1/2 r squared theta. So A equals 1/2 2 squared, and theta is 30 degrees. We write it as pi over 6. I can't emphasize this enough. It has to be in radian mode. And so becomes pi over 3, or 1.05 square feet. And the units are always the units of the radius squared, because you square the foot, in this case, square feet, because you're talking about the area. So square the unit. The unit is in feet, square feet. All right. Find the linear speed of an object traveling in a circular motion. Suppose that an object moves on a circle of radius r at a constant speed. If s is the distance traveled in time t on this circle, so that's the arc length, then the linear speed v of the object is defined as total distance over total time. V is distance over time, or s over t. So that's called linear speed. We also have the angular speed in the same manner. The angular speed omega, the Greek lower letter omega, lower letter case, of this object is the angle theta measured in radians, swept out, divided by the elapsed time t. So linear speed is s over t, omega is theta over t, as a result of the simple definition of that. So we want to find the relationship between the two. We're going to start with this, and we know s is r theta. So we are going to write v is s over t, or r theta over t. So we separate this into r times theta over t. Theta over t is omega, replace it, and the relationship is v equals r omega. Linear velocity is the product of the radius and the angular velocity. A child is spinning a rock at the end of a 3-foot rope at a rate of 160 revolutions per minute, RPM, revolutions per minute. Find the linear speed of the rock when it is released in miles per hour. And reminding everyone, omega is theta over t, which means 2 pi times RPM. Sometimes it's revolution per minute, per day, per second, per hour. So this last one is whatever the units of time is. RP, revolutions per. A complete revolution is how many radians? 2 pi radians. That's why 2 pi times RPM. V is S over T, or R omega. Reminding everybody that 1 mile is about 5,000 280 feet. So having said that, first and foremost, what is given? R is 3 feet. Omega, this is angular speed, 160 revolutions per minute, RPM. And we want the linear speed. V is missing. So one more time. Here's the R, radius. Here's the omega. And here's V. Omega is 2 pi RP. Again, M means minutes, could be RPS. So omega is 2 pi times RPM. So let's do that. 2 pi times RPM, radians per minute, 2 pi times 160. Let's replace it. And that gives us 320 pi radians per minute. Linear velocity V is R omega, R omega. And so that's why when you do problems here, those are word problems, it's really important to read the question, write the given symbolically, so we can go refer back to it. It makes it easy. V equals R omega. Here's R, here's omega. 3 times 320 is 960 pi. And pi is 3.1415, and so on, is 3016 feet per minute. So that would be the speed we would be done if we didn't want it in miles per hour, but we want to go from feet per minute to miles per hour. So how do we change that? Remember the unit conversion. For example, I want to make sure that everybody remembers that. If I said 1 hour over 60 minutes or 60 minutes over 1 hour, these are called unit conversion, right? So the question is, do you need this one or this one? So we want to be very careful with that. Remember, we want ultimately miles at top, hours at the bottom. So as far as miles are concerned, 1 mile is 5,280 feet. So you want to cancel out the feet. So you put the feet at the bottom. That means you put 5,280 feet at the bottom and 1 mile at the top. You want to get rid of the minute. So you put the minute at top, hour at the bottom, 60 minutes over 1 hour. So 1 mile over 5,280 feet, and then 60 minutes over 1 hour. So I hope you see how we cancel out. So let me just again show you. Let's grab this one. This cancels out this one. This cancels out this one. So what is left? Miles per hour. Now you put it into a calculator. 3016 times 1 times 60 divided by 5,280. That's it, because this one. And we get 34.273 as far as the number of decimals, however many they ask you. 34.273 miles per hour. So that's the conversion, and you want to be very careful with. It's very straightforward. There is really not much to. An object is traveling around a circle with a radius of 8 inches. If in 40 seconds, a central angle of 1/3 radian is swept out, what are the linear and angular speed of the object? So first, let's write what is given. Starting from the top, this radius R equals 8 inches. Time 40 seconds, over the course of 40 seconds, a central angle. Theta is 1/3 of a radian. And now we want omega and V. So R is 8 inches. Over the course of 40 seconds, Theta is 1/3 of a radian. So what is omega? What is V? Omega by definition is theta over T. So theta over T by definition. 1/3 over 40 is 1 over 120. 1 over 120 is 0.008 radians per second. Radians per second. V equals R omega. V equals R omega. R is 8. Omega, we found it to be this, but to be exact, let's go with 1 over 120. You can go with that. But if you go with 1 over 120, I hope you see that 8 and 120. This goes away and this becomes 15. Precisely 1 over 15, roughly 0.067 units of R inches per second. So you want to be very careful with your units, okay, as you write. The minute hand of a clock is 6 inches long. So the hour, the minute, the second. And how far does its tip move in 15 minutes? So what we are saying, over the course of 15 minutes, how far does the tip go? So for example, from here to here. So we're talking about the arc length, S equals R theta. First, let's write the given. So R, okay, if the minute hand is 6 inches long, or is 6 inches. Over the course of T equals 15 minutes. T equals 15 minutes. We can find from the 15 minutes that the angle that it covers over the course of 15 minutes is easy to see. And then we calculate S, which is R theta. So first and foremost, 1 hour is 60 minutes. Over the course of 15 minutes, that means a quarter, a 1/4 of a revolution. So 15 over 60 of a revolution. Let's say it did 18 minutes, 18 over 60 of a revolution, okay? So 1/4, and each revolution is 2 pi radians. So this is 1/4, revolution is 2 pi, resulting is pi over 2 radians. So in other words, and it's clear, this is 90 degrees or pi over 2. So we already, in essence, you can see it. S equals R theta, plug in. R is 6, theta is pi over 2, we get 3 pi over 9.42 units of the radius, inches. How about 25 minutes? We do exactly the same thing here. Instead of 15 over 60, we're going to go with 25 over 60. And we simplify this, becomes 5 over 12, and revolution is 2 pi. So we have 10 pi over 12 or 5 pi over 6 radians. We go back here, S equals R theta, R remains unchanged 6, pi over 2 changes to 5 pi over 6, and that is 5 pi precisely, or about 15.71 inches. A 40-inch pendulum swings 20 degrees each second. How far does its tip move each second? I'm going to go with 2 decimals. So let's write what's given. A 40-inch pendulum, that means the radius R is 40, and it swings 20 degrees each second. Theta is 20 degrees, and we want to find S in essence. So 20 degrees, remember everything should be in radians. So first and foremost, let's change the 20 degrees, and remember d over 180 is r over pi, and we get 20 degrees as pi over 9 radians. So just change them, you just multiply it by pi over 180. Either way is fine. So we have that. So each second it covers 20 degrees. That means it covers pi over 9 radians. S, how far? S equals r theta. R is 40 and S is pi over 9. We get precisely 40 pi over 9. And we write it with 3 decimals to make a decision about. Again, I wanted to show you. For the second one, since the third one is 2, doesn't change. 13.96 inches is the final answer. So a quick recap, we are really looking for a distance that it covers, how far it goes. S was r theta. We have r, we have theta. We have to just change the theta to radians, okay, because it's given in degrees. That's it. A water sprinkler is to cover a field of 100 square yards. So it's going to cover this much. And the area it's going to cover is 100 square yards. In the shape of a sector of a circle of radius 15 yards. So it's a circular shape with the radius being 15 yards. What is the angle needed for this rotation? And we need 2 decimals. Let's write the given symbolically because it's a word problem, and then we figure out what's given. So that's the area of a sector. And of course, the formula is 1/2 r squared theta. So area is 100 square yards or 15 yards. What is the angle? Missing theta. We're going to use this formula. A is 1/2 r squared theta. So we have the area, we have the radius, we can find theta. So 100 is 1/2, 15 squared, theta. So it's 225 over 2 or 112.5. This is 112.5. So divide by it. That's theta in radians, 8 over 9. So we are done if we wanted it in radians. Normally, we represent it in degrees. So let's change that to degrees. Again, d over 180 equals r over pi. That's very straightforward by now. You can go with that or just simply multiply it by 180 over pi. Either way, we get 50.93 degrees. So almost 51 degrees. Okay. A windshield wiper's arm and its blade are 30 inches long. So windshield wiper has a portion here that is just moving it. And this is the portion that actually cleans up the window. So that piece and that piece, the total is 30 inches long. If the blade is 24 inches long, in other words, this is 24, so this must be 30 minus 24, or simply 6 for the sake of argument. So if the blade is 24 inches long and the wiper sweeps about an angle of 125 degrees, so the angle that it sweeps is 125 degrees. So from here to here, 125 degrees. How much window area can it clean? And we want to go with 2 decimals. So the very first thing is to write the given. And bear in mind, if this is the arm, this doesn't clean this much. It cleans this much, okay? So the concept is that although this entire thing is 30, but really 24 inches of it can do the cleaning. So you have to write the given, calculate the total area, including the gray area, and because it's easy to calculate using A equals 1/2 r squared theta, and also calculate the gray area and subtract from it. That's the concept. So having said that, what is a given? So this entire thing is 30 inches, which is 24 plus 6 inches in essence. So the blade is 24 and theta is 125. So this is 30 inches. This, as is mentioned, is 6 inches. So if we call this R1 and we call this R2, then arm plus blade, R1 is 30, the entire thing is 30, the blade is 24, and this much is 6, and the angle is 125 degrees. We are interested in the portion that it cleans up the blue area. So we want to calculate the blue area. So we use the entire thing to calculate the blue area plus the shaded area. And then we calculate the gray shaded area and subtract from it. That's the idea. So area, the entire thing is 1/2 R1 squared theta and minus 1/2 R2 squared theta. It's important to know that R1 is the sum of the two, okay? That means 30, that means 24 plus 6, and R2 is the gray one, this one, just the arm, which is 6 inches. So again, you calculate the area, the sector, it starts from here. So the entire thing, including the gray, and then you subtract the gray area. All right, so blade is 24 inches. The R2 is R1 minus 24. We know that this is 6 inches. So R1, the big one, is 30. R2 is 6 inches. We already know that. And theta is 125 degrees. I'm going to assume everybody can easily change it to radian mode, 25 pi over 36. So that is something we need to do. So we calculate the entire area again, the blue one and the gray one, 1/2 R1 squared. That means just use 30. 1/2 30 squared times 25 pi over 36 minus the gray area, 1/2 6 squared 25 pi over 36. That's it. So you put it into a calculator, you do the calculation. The first part is 11,250 pi over 36 minus 450 pi over 36, and you get 300 pi, which is almost 942.48 inch squared. So a quick recap. I want to make sure everybody is comfortable with the concept. So the wiper goes from here to here. This portion of it is the arm doesn't clean up anything. This portion of it is the plane that cleans up the blue area. So we calculate the entire thing, the blue area and the gray area, using the 30-inch arm, if you will, radius. And then we calculate the gray shaded region using this radius of 6 inches. The difference is the answer. Each one uses the same formula, half of r squared theta. And that's what we end up. An object is traveling around a circle of radius 2 meters. It travels 5 meters in 20 seconds. What are the angular and linear speeds? As always, we are going to write the given. R is 2 meters. It travels 5 meters in 20 seconds. That is giving us the speed. So we're going to write 5 meters in 20 seconds. And we want to find V and omega. So R is 2 meters. It travels 5 meters. S is 5 meters. Over the course of t equals 20 seconds, V and omega are missing. V is S over t, so we're going to use this formula to find the linear velocity. S is 5, t is 20 seconds, gives us 1/4 of a meter per second. 1/4 of a meter per second. We also know V equals R omega, which means omega must be V divided by R. If V is R omega, omega V is divided by R. So V is 1/4 divided by R, which is 2. The answer is 1/8 of radians per second. 1/8 of a radians per second. Pretty straightforward, everybody. Again, a quick recap. You write the given symbolically. Radius is 2 meters. The coverage means S equals 5 meters over the course of 20 seconds. And then use the formula to get the answer. A centrifuge force ride similar to gravitron, an amusement ride, spins at 22 revolutions per minute. If the diameter of the ride is 12 meters, what is the linear speed of the passengers in kilometers per hour? Let's write the given. The very first number we come across is this 22 revolutions per minute. 22 RPM, revolutions per minute, is omega. Omega is 22 RPM. If the diameter is 12, R must be half of that, 6. And we want to find V. So again, omega is 22 RPM, revolutions per minute. Remember, revolution means 2 pi, right? Each revolution, a complete revolution is 2 pi radians. So we have to multiply that by 2 pi, that 2 pi RPM. R is 12 divided by 2 because this is not the radius, okay? This is diameter. And now we want to find the V, linear speed. So having said that, first let's change this from revolutions to radians. That means times 2 pi. So 2 pi times RPM. 2 pi times 22 gives us 44 pi. These two are the same. This is 22 revolutions per minute. This is 44 pi radians per minute. Both of them are omega, but we want them in radians per minute. Okay, the units we need to use is radians. That's why we change that. So V equals R omega. V equals R omega. And we get 6 times 44 pi, or 264 pi units of radius is meters, meters per minute. This is in meters, everybody. The radius is in meters because this was 12 meters, right? This was half of that. So 264 pi meters per minute precisely. However, we want to change this to kilometers per hour. Okay. So for example, we know 1 kilometer is 1,000 meters. So, or 1 hour is 60 minutes. So we're going to change them accordingly. So we are going to write 264 pi meters per minute, and we want to change it to kilometers per hour. So we look at the meters, for example. So 1 kilometer is 1,000 meters. Because we want the meters to cancel out, we put the kilometer at top, meter at top. Remember, unit conversion. Again, I want to write this. I want to make sure everybody understands these two are the same. They are unit conversion. If I said 1 kilometer over 1,000 meter, or if I said 1,000 meter over 1 kilometer, both of them are the same unit conversion. Now, which one do we use depends on what we want here. You want kilometers to be at top here. Do you see that? So if you want kilometers to be at top here, you're going to use this one. Now we go with the minutes. Let me just erase this and write for the minutes. I can write 1 hour over 60 minutes, or I can write 60 minutes over 1 hour. Both of them are what? Unit conversion. That means both of them are equal to 1. But which one do I need? Well, I want the hour to be at top, so I need this one. So I'm going to go with 1 kilometer over 1,000, and then 60 minutes over 1 hour. Let me erase my work. 1 kilometer over 1,000, 60 minutes over 1 hour. So basically, you're going to multiply 264 by pi by 1 doesn't do anything by 60 and divide by 1,000. We get 49.763. Now the units are in kilometers per hour. So the unit conversion and the way you do the conversion with the units, you want to be very careful. It's very straightforward. A DVD driver has a maximum speed of 7,200 RPM, revolutions per minute. If a DVD has a diameter of 12 centimeters, what is the linear speed in kilometers per hour of a point 5 centimeters from the disk's center if it is spinning at a rate of 5,400 RPM. A couple of things before we write the given. It's important to know. As it's moving in a circular motion, and here's the center, if something is sitting here, something is sitting here, or here, or here, as they move around, because of the radius, distance from the center, their speed or linear velocity varies, but their angular velocity is unchanged. So I hope it's clear to everybody. So having said that, let me erase my work. So now let's start from the top and start writing. As you can see, the diameter is 12, and the speed is 7,200 RPM. But there is a specific point which is 5. So the diameter, the entire diameter is 12, but we are looking at which location? A location 5 centimeters from the center. So that makes the R 5 centimeters. So we are looking at a smaller circle. So this is the radius. And that one is spinning at 5,400 RPM, and V is missing. Now, one might say, okay, what about 7,200? This is the maximum speed. It's not running at 7,200. It could run at 7,200 RPM. This is the maximum speed. But it is running at 5,400 RPM. It could be any point along this radius, but it is at a point where it's 5 centimeters from the center. It can go half of 12 is 6. It can go from 0 to 6. Okay, as far as the radius is concerned, from 0 to 6, because this is 12. But it is located at 5. So we want to be careful with that. Having said that, again, RPM, revolution means 2 pi. So let's change that to radians. So the very first thing, this has to be multiplied by 2 pi, everybody. Omega is 2 pi times RPM. So 2 pi times this number. And we're going to keep it exact for now. Remember, when you do the calculation, you want to keep everything exact until at the end when you want to report it, if you have to, do the rounding. So 10,800 pi radians per minute. V is R omega. And R is 5 for this case. We want to be very careful. Again, this is the diameter and this is the maximum speed. So R 5 times 10,800 pi results in 54,000 pi. Now units of the radius, centimeters per unit of time, RPM minutes. So I want you to be very careful with the units and how they come. So we go back to the question, okay? So we have the RPM, okay? And we have the speed and we want it in kilometers per hour. So we are going to write this 54,000 pi centimeters per minute is going to be kilometers per hour. So again, we're going to repeat the same concept. How do we do the unit conversion? For example, we know 1 meter is 100 centimeters. We know 1 kilometer is 1,000 meters. We know 1 hour is 60 minutes. How do we write them? We write them such that we end up with the hour at the bottom, kilometer at top. Okay, so again, let me just write one of them. So I can write 1 meter over 100 centimeter, or I can write 100 centimeter over 1 meter. I can write 1 kilometer over 1,000 meter or I can write 1000 meter over 1 kilometer. And I hope you see that because the kilometer is at top, we need this one. 1 kilometer over 1000 meter. And since we want to keep that and want to get rid of the meter, then we are going to use this one with this one. And of course, we want the hour at the bottom, so 60 minutes over 1 hour. So let me erase my work. This is how you do that. So okay. M cancel out the minutes. CM cancels out the CM, that means centimeters. Okay. Minutes. So I want you to just look at the units. At top, you have kilometers only. At the bottom, everything is gone and you have hours only. So 54,000 pi times 60 over 100,000. And it becomes 101.8 kilometers per hour. Really straightforward, everybody. The radius of each wheel of a car is 15 inches. So the radius is 15 inches. If the wheels are turning at the rate of 3 RPS, revolutions per second. Okay, this last one is the time. RPM, RPS. How fast is the car moving? Express your answer in inches per second and in miles per hour. First thing first, what is given? This tells us R is 15 inches. So you're dealing with the word problem, write the given. I can't emphasize this enough. R is 15 inches. RPS, omega is 3 RPS. What is missing? Linear velocity, V. So having said that, again, first and foremost, this can't be revolutions, has to go to radians. So you have to, revolution must be replaced by 2 pi. So 2 pi times RPS, that means 2 pi times 3, that gives us 6 pi radians per second. V is R omega. V is R omega, or we have it to be 15. Omega in radians per second is 6 pi. We get 90 pi inches per second. This is exact. We change the pi to 3.14159 and we get 282.7 inches per second. We would be done if we didn't want it in miles per hour. And please understand, this part is elementary algebra. It's conversion of units. So having said that, we are going to write this 90, and to write this, you want to remember the rounding takes at the end. So keep it at 90 pi rather than this number. 90 pi inches per second, we want to go with miles per hour. Okay. So we know 1 mile is 5,280 feet, and we know 1 foot is 12 inches. So again, just one mile over 5,280 feet, or 5,280 feet over 1 mile. I hope you see that you need this one because the miles at top. And then if that one is at top, you go with 12 inches over 1 foot, or 1 foot over 12 inches. Remember, you want to cancel them out. So it's 1 foot over 12 inches. And 1 hour is 60 minutes or 3,600 seconds. And the hour must be at the bottom. So I hope it's clear to everybody. So 1 foot and 12 inches are the same. 1 mile and 5,280 feet are the same. And 3,600 seconds and 1 hour are the same. And notice here's what happens with the units. Let me, inches and inches cancel each other. Feet and feet cancel each other. Seconds and seconds cancel each other. So as far as the units, and I want you to pay attention, just the units. At top, you have nothing but miles. At the bottom, you have nothing but hours, and that's what we want. So it's 90 pi times 1 times 1 times 3,600 in the numerator, 12 times 50 to 80 in the denominator. And you do the math, you end up with 16.1 miles per hour, as far as the number of decimals, whatever they ask you. So I hope you have no problem with the conversion of units. It's very straightforward, everybody. The mean distance of Earth from the sun is 9.29 times 10 to the power of 7 miles. Assuming that the orbit of Earth when around the sun is circular, and it's not. It's oval, okay? It's elliptical, if you will. And that one revolution takes 365 days. Find the linear speed of the Earth in miles per hour. So they have given us the distance, okay, in essence, and distance is different depending upon a couple of things. So let's write the given. This is the distance from the sun, that is r. This is the angular speed omega. And what is that? One revolution over the course of 365 days. Therefore, what we need to do, r, we write it, omega, one revolution per 365 days. And we want to find the linear speed in miles per hour. So this is revolutions per what? Year. We make it to days and then hours. Please understand this was one revolution, okay, per year, or one revolution per 365 days. And now we are going to change it accordingly. Remember that omega by definition is theta over t. So let's go with that. I want to make sure we understand how this thing works. Omega is theta over t, one revolution per year per 365 days. One revolution is 2 pi radians. So this is radians per day, 2 pi over 365 radians per day. Now, in one day, there are 24 hours, and we want to go with that because of this. In one day, we have 24 hours. So this one times 1 day over 24 hours is to cancel each other. Okay. So you get pi in the numerator, 365 times 12 in the denominator, radians per hour. Radians per hour. So, to recap this, if there is a complete revolution per year, there is a complete revolution per 365 days, and there is pi over 12 times 365 radians per hour. V equals r omega. So all we have to do, multiply this omega by this r, 9.29 times 10 to the power of 7 miles times this one. So the units now will be miles per hour. So this number divided by this number results in 66,633.324 miles per hour. So the Earth is spinning around the sun at about almost 60 7,000 miles per hour, almost. It's not quite that. Imagine that, 67,000 miles per hour. Two pulleys, this one and this one, bigger one, smaller one. One with radius 2 and the other one radius 8 inches are connected to a belt. See the figure. If the 2-inch pulley is caused to rotate at 3 revolutions per minute, determine the revolutions per minute of the 8-inch pulley. What about radians per minute? Hint, the linear speed of the pulleys are the same, both equal the speed of the belt. Okay, so first and foremost, let's write the given. So this one, the smaller one, let's call it R1 is 2, the larger one is R2 is 8, and omega 1, therefore the smaller one is 3R PM, we want omega 2. So that's the given and what is missing. So having said that, they have equal speed. V1 and 2 are the same. That means R1 omega 1 and R2 omega 2 must be the same, because V equals R omega. So R1 is 2, omega 1 is 3, R2 is 8, omega 2 is missing in an action. So this is 6 divided by 8, or 3/4 RPM. 6/8 or 3/4 RPM. But we want it in radians per minute, just multiply by 2 pi. 1.5 pi radians per minute. Again, we don't have to change that, we just kept it, and then eventually we can change that accordingly. I hope everybody is okay with that. Very, very straightforward. Earth rotates on an axis through its pole. Okay, here's the axis. The distance from the axis to a location on Earth, 40 degrees north latitude, is about 3,033.5 miles. That's the radius in essence. Therefore, a location on Earth at 40 degrees north latitude is spinning on a circle of radius 3,033.5 miles. Compute the linear speed in miles per hour on the surface of Earth at 40 degrees north latitude. Okay, first and foremost, what is given? We have to write the given. So R is this, 3,033.5 miles per hour. And omega is 1 revolution per day, right? A complete revolution per day, right? Earth rotates turn, okay? And so we want the velocity, linear velocity in miles per hour. Now, omega is 1 revolution per day. We want to multiply it by 2 pi to make it into radians. So it becomes 2 pi radians per day. And 1 day, 24 hours, divide by 24. 2 pi radians per day is pi, 2 pi divided by 24. 2 pi divided by 24 becomes pi over 12 radians per hour. So first, we want to make sure we get to the proper units. We want it to go per unit of time, hours. V equals R omega. Here's R, here's omega. And we get 794.17 miles per hour. Almost 800 miles per hour. In some areas, it's about 1,000 miles per hour. in the equator, for example. So the speed, so it turns around itself with the speed of 800 miles per hour, with that location, of course. To approximate the speed of the current of a river, a circular paddle wheel with radius 4 feet is lowered into the water. If the current causes the wheel to rotate at a speed of 10 revolutions per minute, what is the speed of the current in miles per hour? Again, what's given? Let's write the given symbolic. So we're going to start from the top, start reading radius. R is 4 feet. And this one is what? Revolutions per minute. Omega is 10 revolutions per minute. V is missing. R is 4 feet. Omega is 10 revolutions per minute. Linear velocity is missing. So first and foremost, we have to change this because it's revolution. We have to multiply it by 2 pi. A complete revolution is 2 pi radians. And so it becomes 2 pi times 10, which is 20 pi radians per minute. So pay attention to the fact that it has to be in radians. V equals R omega. V equals R omega. Again, so we go back to the given. R is replaced with 4, and omega, we found it to be 20 pi radians per minute. And 4 times 20 pi or 80 pi, the units would be units of the radius per minute. That's why it's feet per minute, everybody. You want to change this to what? Miles per hour. So this is 80 pi. You want to keep it exact. Feet per minute. 1 mile is 5,280 feet. 1 hour is 60 minutes. By now, we know how to write that. Remember what you want. You want miles to be at top and hours to be at the bottom. And this cancels out this one. This one cancels out this one. So 80 pi times 1 times 60 over 5,280. We get 2.86 miles per hour. So this will help us find the speed of the current. 2.86 miles per hour. A Ferris wheel whose radius is 30 feet takes 70 seconds for 1 revolution, 2 pi radians. What is the angular velocity in radians per second? What is the linear speed in feet per second for this wheel? So first and foremost, you have to write what's given. We reread that. The radius R is 30 feet. Omega, 1 revolution over the course of 70 seconds. And we are looking for V. So this is 1 revolution over 70 seconds. We have to multiply it by 2 pi because revolution is 2 pi radians. So 2 pi over 70 seconds or pi over 35 radians per second. V equals R omega. R is 30, omega is pi over 35. Six pi over 7 precisely. Roughly 2.69 feet per second. So a quick recap. When you read this question, write the given, the radius, and omega, revolution, per second is found and we change it to radians per second, V equals R omega will give us the answer.